Section 1.3 Properties of Exponents. This section, we will look at the natural number and integer exponents, properties of exponents, scientific notation, and problem involving geometric formulas. By definition, the exponents, if A is any real number, N is any natural number. Natural number, recall it is the same as a positive integer or the counting number. Then the product of n factors of A is in the form of A to the power n or the superscript n as the product of A or A times itself n times or the total n factors of A. It is called raised A to the n power or the n power of A or A to the n power. For the properties of exponents, as A not equal to 0, A to the first power is A or the same as itself. That means only one factor of the A. A to the 0 is always 1. The first one is called the product property. A to the n times A to the m is A to the sum of n and m. The second one, A to the n over A to the m, which is the quotient property. The result is A to the n minus m, or the exponent of the numerator subtracted by the exponent of the denominator. Number 3 is called the reciprocal property. A to the negative n is the reciprocal of A to the n, or you change from negative exponent to the positive by doing the reciprocal of the expression. Number 4, A to the n raised to the power m. So we have A to the product of n and m. Number 5, the product of A and B raised to the n power. It is the same as to distribute the n or the exponent to each factor. So then it becomes A to the n times B to the n. Number 6, or the last property, A divided by B, the quotient raised to the power n. Similar to the property 5, so you just distribute the exponent to the numerator and denominator, which is the same as A to the n divided by B to the n. Make sure the B is not 0. Let's work on some examples. Number 1, we're going to simplify the following expression, writing your answer with only positive exponents. The first one, or part A, as you see the whole quantity raised to the power 0. Any non-zero term raised to the power 0, the result is always 1. For part B, we have x to the 4th times x to the 7th divided by x to the 3rd. We have the product of the two factors and divided by x to the 3rd. So we're going to work on the numerator using the product property. We have x to the power 4 plus 7 because it's the product. We have the sum of the exponent. And then divided by x to the 3rd. The numerator, now the exponent becomes 11 divided by x to the 3rd. After we simplify to only one factor on the top, one factor on the bottom, we apply the quotient property. So we're going to have x to the power 11, which is the exponent of the numerator, subtracted by 3, which is the exponent of the denominator. And then we get the simplified solution as x to the power 8 as a final result for part B. Now let's move on to part C. In part C, we are going to simplify the second power of the quotient 2a divided by the quotient 2a and b to the negative 3rd. Let's work on the quotient or the expression inside of the parentheses. From the property that a to the power negative n is 1 over a to the n. Or vice versa, if you have a to the n, is the same as 1 over a to the negative n. Therefore, the denominator, which is b to the negative third, now it can be rewritten as b to the third, or you just change from numerator to denominator, or vice versa when you have the negative sign of the exponent and change to the positive exponent. So right now you have 2 times a times b to the third all together raised to the second power. And next we're gonna distribute the power to each factor. Gonna be 2 to the second times a to the second times b to the third quantity to the second power. Simplify one at a time. 2 to the second is 4. A to the second is as a to the second. And then the last portion, we're going to use a property that from b to the n all to the power m is the same as b to the n times m. That means we're going to multiply 3 and 2 together and becomes b to the power 6. So this is our solution for part C. And then the last one, we have more factors involving in this expression. So we're going to do one piece at a time. Starting with the negative power or negative exponent, we're going to rewrite as a reciprocal. So I'm going to draw the division line here. So x to the negative fourth now becomes the bottom one as x to the positive fourth, together with the 3, z, and y to the fifth. And then the numerator in the quantity, we have x to the second times y to the negative second to the power 3. We can use the distributive property of the power and then distribute it into each factor in the parentheses. It becomes x to the power 2 times 3, which is 6. And then y to the power negative second times 3 becomes negative 6. And then we're going to simplify more by rewriting negative power as the positive power and then rewrite it as a denominator instead. So x to the 6 remain on the top, x to the 4th times 3 times z times y to the 5th, now times y to the 6th because the numerator negative power now become denominator with the positive power. And then we work on each variable, simplify each one, and also the coefficient. For this case, we have just one real number or the one coefficient factor, which is 3. And in the denominator, we're going to rewrite it as, okay, on the top here. So that's x to the 6th over x to the 4th, and then 3. I'm going to line them up in the nice order here. So 3 times x to the 4th times y to the 5th, y to the 6th, and then z. And take care of one variable at a time. The numerator, x to the 6th together with denominator x to the 4th as a quotient form. Now it becomes x to the power 6 minus 4 or x to the second, and the coefficient 3 remain on the bottom. The y to the 5th and y to the 6th as in the product form. So we can combine the power or the exponent together. So it becomes y to the 11 and z only one factor. So here is the final form of this expression in part D.